this title, obviously written by marketing, prickly yet cool hedgehog-inspired innovations in room temperature biospecimen preservation. Essentially, a talk about biosample storage and shipment. So, Atelerix as a company is here to turn the cryologistics world on its head, becoming every laboratory's favorite shipping companion across the globe, redefining how labs operate, trimming costs, and giving a jolly good boost to reducing carbon emissions worldwide. Essentially, we have a technology that preserves cell models, tissues, cells, viruses, blood products, multiple biological specimens at room temperature. And the reason we do this is essentially due to the shipment anxieties that everybody faces when they're trying to move samples around. This could be artifacts in results, which could be resultant of poor quality samples when they arrive with you at the processing site or laboratory. It could be anxiety over samples getting stuck in customs and not knowing when they're going to turn up. And really, sometimes you've got high stake shipments, high value shipments. They might be rare tissues, for example, disease specific samples. And it's really gambling with your project success. Your project might not be successful if those samples don't get to you. Often, if samples are frozen, they may get thawed if holding customs, and you end up having to repay for your samples, recollect your samples, and it really puts a delay on projects. If you are using fresh samples, you're often juggling with sample delivery times and making experiments and process incredibly stressful. You don't know when that sample is going to arrive with you. You may need to process it as soon as it arrives, which is often the case. And that just makes workflows incredibly inflexible. And another reason we do this is cryologistics killing our planet. Obviously, it is highly unsustainable shipping on dry ice with the high manufacturing costs of dry ice and the high tear weight of consignments. It means that shipping at room temperature is much more sustainable. So it doesn't have to be this way. There is another way. We specialize in increasing the shelf life of fresh biological samples. It's essentially cryo-free, hassle-free ambient logistics where we can amplify the fresh sample shelf life from hours to weeks. And what this does, it enables complex tissue models, sensitive cells, and therapies to be shipped easily. All of our products are supplied in kits, so they are very, very easy to use. It says all you need is a pipette, but some of our products don't even require a pipette. They're that simple. And we maintain viability and functional performance of a number of different biospecimens. It's easy to validate, it de-escalates shipping, it makes it easier, and it slashes costs by up to tenfold. So really, what we aim to give is a flexible, low-cost supply chain and workflow from sample collection to final application. And this really keeps money for science, not for shipping companies. You don't have to pay thousands of pounds to ensure that your biospecimen gets from the site of collection to the site of processing. And the cherry on top is we use seaweed-derived hydrogels. These are natural, non-toxic and renewable. All of our components and kits come in sustainable bio-based packaging made from a renewable resource. And all the components in the actual preservation kits themselves are pharmaceutical grade and GMP compliant, so we can rely on the quality of those components. And the shipping method itself, we have calculated to be 99.7% lower in terms of carbon emissions compared to shipping on dry ice. So it really does give you a huge saving in terms of carbon emissions. So it's friendly on the planet and on your budgets. Sounds interesting, but what's with all the hedgehogs? This is something that we get asked a lot because it may seem a little bit random that we have loads of hedgehogs when we're talking about storage and shipment. But the name of the company, Atelerix, Atelerix itself is a genus of hedgehog. Specifically, our company is based around the African four-toed pygmy hedgehog. This is a type of hedgehog that goes into immediate torpor at 20 degrees. That's important because when we're considering room temperature shipment and the principles behind hypothermia, our products essentially allow cells to be held in a hypothermic state. So there is a reason for hedgehogs being there. To explain that a little bit further, the principles of hypothermia, obviously it's going from a higher temperature to a lower temperature. In mammalian normothermic conditions, 32 to 37 degrees, cells are metabolically active and they have a fluid membrane. This allows the cells to be doing what they do. All sorts of physiological functional processes occur. As you reduce this temperature below 32 degrees, enzymatic activity and subsequent metabolic processes slow down to such a state that the cells almost go into a state of animation. They're paused essentially. They're not doing anything. They don't have the energy to do anything, so they are just stuck doing nothing. And this is what enables you to store cells in a static state outside the body or the incubator. But if you just try to do this in medium, the cells themselves are susceptible to membrane damage and subsequent cell death. What our gels do is we stabilize cell membrane integrity, which allows samples to be held at room or refrigerated temperatures for extended periods. Essentially, we prevent all of the things that are coming into the cell and damaging that membrane. We're preventing that unregulated transport. And so this enables essentially for you to hold the cell in place and prevent it dying. And because we are essentially working on the cell membrane, it makes our technology applicable to anything that has a lipid membrane. This is why we're able to apply our technology to anything from a small unit of envelope virus all the way up to larger tissues and blood products. So using this, fresh cells, cell models, tissues, viruses can be stored for up to 2 weeks without the need to freeze. The process itself for encapsulating your samples is very, very straightforward. It couldn't be easier. This is an example of one of our kits, and essentially very quick process. You order, you receive your kits, you add your sample to gelation beads. The sample cures in situ, protecting your samples, and then you add a release buffer to release your samples again. So the actual hands-on time for encapsulation is about 1 minute, and to release your sample, hands-on time is about 1 minute with a 10 minutes incubation. Once you're through with that process, you can rejoice in quality data because your samples are preserved reproducibly. And that's not all. We cover all biosample types. It's the same principle technology in our kits, the alginate-based hydrogels, but they have been optimized for different biosample types. Cytostore is optimized for the preservation of cells and viruses in vials, so they're in suspension in the gel within vials. Well Ready is optimized for in-plate models, so you can preserve the cells, cell models, tissue models, organoids, etc. in plates. Tissue ready is optimized for certain tissues and organoids. The majority of tissues we recommend Tissue Ready Plus. This contains a component that has been optimized for tissue preservation. And we have two products for blood products. So Blood Ready is for whole blood, and Leukostore is for leukapheresis. So really we try to cover all biospecimen types and optimize products for ease of use and applicability to that biosample type. And with that short introduction, we have got time for a poll. I'm going to switch to Robert, who is going to start the poll and provide you with an opportunity to answer some questions about biospecimen shipment. And then I'll do a quick review after. Over to you, Robert. So, in terms of the first question, what biosamples are people working with or shipping? So actually the leader on this group is tissues with 65%. It looks like people also ship bloods and cells. So they're up with 50 and 55%. So it looks like people generally don't ship one single biological sample. It's often a range. And often that's the case with tissues and matched blood samples and also cells that are extracted from tissues. So that is good to see. And then only a few people ship viruses. So in terms of the platform in biobanking, that all makes sense. So thank you for that. What do people currently use for biospecimen preservation? By far the highest is dry ice. That is not surprising. I think it's a very familiar way for people to ship samples, but of course it necessitates them being frozen. Of course, if you're shipping tissues, maybe it's a good idea to ship them fresh to maintain the physiological mix of tissues, but also hike up the viable cell recovery as much as possible. I'll talk about that a bit later. Nice to see that a lot of people ship at refrigerated or room temperature. So that is great that people are doing that. In terms of people being involved in a situation where shipment has been delayed and what the impact is, 50% of people have experienced sample wastage. This is a big thing. Of course, if you're waiting for a individual precious sample to come in, if that gets wasted, it's very difficult to get that resampled. Some people have had to work late or into the weekends. It's surprising that's only 18%. Obviously, it's not the younger scientists on the call because that can often happen quite frequently. But a lot of people experience delays to projects, so that's interesting. In terms of people considering implementing room temperature preservation into their workflow, 30% say yes, definitely. Great. 40% say maybe if it's cost effective. Okay, our products are very much cost effective. And only 12% prefer traditional methods, 18% not applicable to me. So the vast majority would want to consider room temperature shipment, which is very nice to hear. And in terms of the biggest impact of room temperature preservation in the next 5 years, that's very much split between clinical and diagnostics and biobanking and research institutions, which is no surprise. And the majority of people seem to ship or receive samples between 1 and 10 times a month. So the top two. So that's very good to know. I think that's all the poll feedback. I think that's very interesting and relatively biased to certain answers. So the collective thought is high. or the consensus is high, I should say. I'll return back to the presentation. And what I wanted to do was really talk about um, how our technology preserves cells, the use cases, and talk through really how it can be implemented. So our products have been validated in over 70 biosample types. I think I did a bit of a tot up the other day, and it's close to 80 now. That's work that we've done ourselves in Atelerix and also users of our products who have used our products externally. So really, we cover quite a large area, and people use our products for a vast number of uses. Anything from delivering ocular cell-based therapies in clinical trials in India. So this is increasing the accessibility of cell therapies without the need for cryologistics. Enhancing cancer collection for increased flexibility. Of course, taking a tissue or resection or biopsy from a patient, getting it to the lab within a window of 24 hours is very difficult. We extend the shelf life to increase the flexibility of that supply chain. All the way to shipment of organoids, which are often models that can't be shipped via any other means. They're difficult to freeze and it can be very, very tricky. So we offer a solution that stabilizes those organoids without needing to freeze. And I mentioned earlier we had a range of products for different uses. And what I'll do very quickly is touch on each of those products to show how they really make a difference. So CytoStore, I mentioned, is used to ship cells with ease without the need for cryopreservation. So these are preserving cells in vials. And what it's particularly good at is protecting fragile cells that would usually be dead within hours. And you can see that on the graph on the left, that those particular cells, these are limbal stromal cells, limbal corneal stromal cells. By 3 days, if you just have them in medium, they're totally dead. But you can extend that up to 5 days and you still get over 80% viable cell yield. Aside from viability, that's the first thing you want to look at, but you want to ensure that those cells are still functional. On the right is an image of, it's essentially a corneal wound healing model. And what that demonstrates is that the potency, so the ability for these cells to prevent scarring in a corneal wound model, is maintained to exactly the same level as non-stored cells. So you can maintain the cells as good as fresh. CytoStore itself has been tested successfully with over 35 different cell types or envelope viruses and preserves viability, phenotype, and function for up to 2 weeks. This really depends on the cell fragility. Some cells are innately more fragile than others, but we look to preserve at 5 to 7 days on average. It's usually about a week that our customers use our products for preserving their cells. And what this enables is global distribution during that 5 to 7 day period. Cells are easily encapsulated, shipped, and released, and it's a very cost-effective process. And 95% of samples perform best at room temperature. There are a few cells that are actually happier at refrigerated temperatures, but what we found is that most are happy at room temperature. And we're always available for consultation to suggest shipment temperatures for particular cell types from the experience we've had. Well Ready is used to ship ready-to-use assays and complex models in plates. This is another big issue, especially as we are moving towards replacing animal models in drug development and early discovery, and also basic research. Actually, having access to complex physiologically relevant models is a major need. But often, the more complex the model gets, the more difficult it is to freeze, the more fragile it is. How do you ship it? So Well Ready is really an answer for this, and it's designed for both cyto protection and mechanical protection. What that means is it protects those cells during hypothermic or room temperature shipment, but also offers a mechanical support to prevent shearing or damage of fragile cells in monolayers or 3D structures. And this is just demonstrated by a couple of those images there. That's cortical neurons, which are very delicate, and you can really see how much they're sheared if they are just shipped in a plate without Well Ready, but Well Ready completely protects it. And also hepatic organoids, you can maintain that vacuolar structure in Well Ready. If you are shipping in medium, often those organoids will just fall apart. So the product itself contains 3 gel layers for optimal protection. It works on anything from model layers to engineered microtissues, 3D printed models, sculpture insert models, organoids. A range of different biological samples can be preserved in multi-well plates. And it preserves phenotype and function, again for up to 2 weeks. And cells are easily encapsulated, shipped, and released. Again, 95% of samples perform best at room temperature. Same case as with CytoStore, same rules apply. Everyone, or a lot of people are interested in tissues. Of course, tissues for biobanking, enabling the shipment of fresh tissues to then allow you to process at a central site is advantageous. But also, if you are needing fresh samples to be the best quality for the derivation of cells or dissociation of cells from that tissue for cell model establishment. So this shows how Tissue Ready Plus enhances the flexibility of fresh tissue acquisition and processing. Um, it preserves viability and recovery of cells. You can see that on the left graph, where this is esophageal cancer tissue that has been shipped for 4 to 5 days at room temperature. And you can see in the orange bar how you recover almost 100%, about 90% of both normal cells and cancerous cells. And if you were trying to do that just in medium, you recover probably, well, about 20% of the cancerous cells, and the normal cells also are very attenuated in terms of recovery. So you can really kind of maintain that quality for cell dissociation and subsequent use. The product also preserves tissue integrity by enveloping and protecting the sample. And you can see on the right a load of images from samples that have been stored and then fixed and then processed for histological staining. And on the far right, the medium control, everything is pale, everything is a bit squidgy. Some areas do not stain well at all. In Tissue Ready, you're able to protect and preserve that integrity and staining profile. So the product is validated against multiple healthy and cancer tissues. You can get a 5-fold extension to fresh tissue shelf life, so you can use it within 4 to 5 days rather than within 24 hours, which is often the cutoff point for fresh tissue. This allows you to build flexibility into supply chains and workflows from collection all the way to processing. So samples no longer need to be processed immediately on arrival. That's why I asked in the poll whether there are people that have had to work late or stay into the weekends, because we often hear this a lot because people don't have the flexibility to use those samples when they would want to. Less than 1 minute's hands-on time for this product really is just pop your tissue in a vial. The gel will set in situ, and then all you have to do is add a buffer to release your sample at the other end. So very simple, and we've had a number of clinical operators use this product very successfully. Samples can then be used fresh, or they can be fixed and frozen for long-term storage. So if you did want to remove any manipulation or freezing, or if you're having difficulty for your site collection sites to actually conduct your protocols in a manner that is suitable for yourselves, you can always centralize that to your research area or biobank or wherever you're using that sample. And I'll just touch on the blood products. People are very interested with bloods. What our products do are essentially preserve viability and also preserve the granularity of blood samples. So Blood Ready is specifically for whole blood. There are lots of pies on the left, hence the pie hedgehog. That really shows how well Blood Ready is able to preserve fresh blood over a 3-day period. You're able to recover all the T cells and the subpopulations of T cells, which are the quite rare populations, which are often lost in fresh samples, which are stored for periods beyond 1 day, really. You recover all the NK cells and their subpopulations, all the ILCs, all the DCs, dendritic cells, all the monocytes, and all the B cells, and all of these subpopulations within those compartments. The only real loss you see is in granulocytes, and unless you are looking at granulocytes specifically, these are often deemed a contaminant. So really, a lot of people aren't bothered about those. But that granulocyte loss does not influence the viable cell populations around them. So you're still able to preserve and isolate them if required. That's a good point there in that this is great for flow cytometry, but you are able to isolate cells from the whole blood using standard methods, and they remain viable and functional post-isolation. Also, incredibly important for flow cytometry is the epitope presentation. Often epitopes in whole blood on leukocyte populations are quite labile. They will fall apart, they will degrade if the sample is not protected. So a lot of people with whole blood either use it as quickly as they can, within hours to under 1 day. 1 day is probably the limit. A lot of people fix the samples. This is a common fixative that our product has been compared against. So we're looking at blood preserved in Blood Ready versus blood that has been fixed with cytochecks. And what we can see across the panel of 93 different epitopes is that 75% of those epitopes are preserved better in Blood Ready compared to cytochecks. So this is significant improvements on certain epitopes with our product. And those other 25%, they've been mostly unaffected by our products, but are still there. So what this allows you to do is to improve your panel design and really channel in to certain populations that may be difficult or lost or underexpressed previously. So Blood Ready extends shipping times. It allows you to look at all major leukocyte populations and those granular populations, conserve unstable surface epitopes. You can isolate cells with greater than 90% viability using standard methods and then return those to culture and maintain cell competence. I haven't got the data on this, but if you were to store whole blood for 3 days, you can recover cells from them, but then post-rest in the incubator, they just fall off straight away. Our product prevents this. And it's available in multiple sizes from 0.5 ml to 10 ml. And Lucas Store, this is for leukapheresis. This is quite similar. This is the last product I'm going to talk about. It's similar, but it is specifically for those larger concentrated blood volumes. It preserves all the major cell populations without protection. They get distorted, and you can see in the bottom pie that the file is almost the same as fresh. Importantly, increases the viability of cells of interest, the viable yield. And this is an example of T cell recovery from apheresis after being stored for 5 days at room temperature. In the red bar with blood ready, with Leukostore, I apologize, you get almost 100% of the T cell recovery. But if you just have that with no protection, it's less than half and highly variable. So this is great for yielding high numbers of viable lymphocytes. So you can maximize the recovery of cells up to twofold after 5 days, reduce variability in yield for greater downstream process consistency. Importantly, increase the geographical distribution of fresh leukapheresis. And again, this is available in multiple sites depending on requirements. So to summarize, the future of biosample logistics, we like to think that cryologistics is dead or dying, because this solution is tenfold cheaper. So you can keep money for science, not for shipping. There are 99.7% fewer emissions, so save the planet while saving your cells. Zero compromise. Don't compromise on viability, function, or integrity. Our technology maintains that intact. You can have any sample anywhere, really increasing the accessibility and equitability of biological samples because you don't need any specialized network. And it's ready to roll. Simple, fast, seamless, can be integrated very quickly into your SOPs. So if you wanted to try it, get a free sample, try it, love it. Just contact us, either myself, CSO, or Alistair, CEO, and we're more than happy to provide you a sample, talk about what your needs may be, get the product in your hands and really see how it works with your cells and your processes. And with that, that's all. I will finish the presentation and hand back to Robert for any questions.
Okay, fantastic. Thank you very much, Steve. That was really interesting. So now we have the opportunity for questions, and I see that we've got 5 questions already, but maybe there'll be some more coming. And so I just wondered if I could ask a quick question while people are thinking about adding any additional questions to the Q&A, and that is concerning the shipment of tumor samples. Biosample Hub aims to put sample providers in contact with biotech companies or pharma companies. And very often, these companies are requesting viable tumor tissue. And so generally speaking, if the requester is, say, in the USA, and well, we would tend to try and find a tissue provider in the USA to avoid the delay that it would be involved in shipping from Europe to the USA. So we wouldn't go to a biobank in Europe for that, um, unless the biotech company was willing to accept samples that had been preserved in some way according to traditional preservation
Yeah.
methods. And generally speaking, traditional preservation methods would mean um, disaggregating the tissue into fragments, small fragments, and then putting some medium containing DMSO um, onto the cells and then freezing and then shipping. So freezing in liquid nitrogen and then
Mhm.
shipping. Uh, so I wonder what your thoughts are about that, and you know whether it might be better to use something like your tissue solution.
Mhm.
What do you think about that?
Yeah, I think it really depends on how people's supply chain is laid out. What we aim to do with our products is reduce the amount of manipulation that has to occur next to the site of collection, because that's often where it is difficult to get people to do anything extra with samples. So what we enable is it's almost like that wheel and spoke approach that you can have a number of different collection hubs and ship those to a central hub for processing. So each of those different collection sites that you're using, they may have different methods for disaggregation and then freezing. What our tech allows you to do is just to put that tissue into the same process, just put it into the gel, get it shipped to that centralized site, and then have it processed under harmonized protocols. And this reduces the amount of chance of error and lack of consistency in the quality of those samples. So that's really what we aim to facilitate.
Mhm. Mhm. Okay, great. And yeah, I've often wondered about whether it was good for cells to add DMSO to them. And recently I see that, there's some reports coming out that DMSO is actually um, causes extreme changes. One paper says extreme changes in microRNAs and
Mhm.
alterations in the epigenetic landscape, indicating that DMSO is not inert. This is a paper in 2019 in
Yeah,
yeah, scientific reports, but there have been a number of other in recent years, and so I just wonder, I'm kind of hopeful that your approach is a gentler alternative.
it is. It's interesting you say that actually, Robert, because you introduced my PhD in pharmacology at the start. I used to use DMSO as a control in my screening, and that often had more of a pharmacological effect than the small molecules I was screening. So absolutely not. It is not bioinert. It is toxic. Um, Yes, it is useful for freezing. The cells aren't exactly the same after you thaw them. You often have to put them through a number of passages before you get them to senescence, of course, before they return their proper characteristics. So it's not ideal. Our technology is completely bioinert. So it doesn't enter the cell, it doesn't interact with the cell, cells can't stick to it, they can't bind to it. It just sits around the outside and does nothing except from protects that lipid membrane from falling apart at room temperature.
Great, thank you. Okay, so we've got a few questions from the audience. So Royston asks, is are your solutions compatible with pathogen detection? Sorry, are they compatible with pathogen deactivation technologies against bacteria and viruses?
Um, a lot of the deactivation technologies that I know of, or deactivation approaches, involve actually killing or attenuating that pathogen, be it a virus or bacteria. We haven't really worked with bacteria, but I know that with viruses. Um, so because we are looking to keep our samples viable and alive, we haven't really looked at that. It may be um, something that's is not necessary. Uh, yeah, that's all I can say with that, I think.
Okay, okay. And another question from Royston. Is it a risk that samples may warm above the 32-degree level during transport? Is that a risk?
There is a risk, especially if you are shipping in hot climates. We recommend the use of controlled room temperature boxes. We can recommend those very easily. We're soon to supply them, actually, which are just small uh, boxes with phase materials packs in. So nothing that unusual. And what these do is really maintain temperatures at a mean of 20 degrees so that the temperature doesn't go too far out. If you do go too far high, cells will start metabolizing again. They will start consuming metabolic substrates and start gaseous exchange. And you don't want it in a sealed tube because they'll soon die. We've used CRT boxes for shipment in India. We've had stuff get held in Indian customs for about 10 days with temperatures up to 40 degrees using these boxes, and the cells have been absolutely fine. So there are very cheap, effective ways around controlling the temperature.
Okay. We have a question from Maria, who says, is it possible to suspend samples in your fluids and then freeze them to -80 or cryo-freeze them, then thaw, and then use the samples as required?
It is. This is part of an ongoing project that we are doing at the moment. What we are aiming to do is to integrate our product with long-term freezing, so that you can freeze the products within the gel, take them out of freezer, um, be out of cryo storage, and then thaw them and ship them at ambient to avoid the requirement for cryo shipment, or thaw them or ship them on cryo. And if it does get stuck, you've got an insurance policy essentially that will thaw, but our gel will maintain active to preserve the cells at room temperature. So we are looking at these aspects, but currently we recommend the ambient shipment over the cryo.
Okay, got a question from Staney. Have you tested the RNA or microRNA expression level um, in tissue stored in the classical manner versus the tissue-ready technique? So have you compared RNA or microRNA expression um, in tissues stored in the two different
Mhm.
ways?
Um, Not microRNA, but mRNA. We've looked at the recovery of that from tissues, and we can see clearly that the integrity is maintained and the yield is maintained. Um, so we would assume that that would be the same case with microRNA. What we really do is same things that we've seen in cells. The arrest of cells at room temperature is enough to pause any change in uh, gene expression. Really, gene expression kind of returns to the same once you take those cells back to physiological temperature. Um, and because you are maintaining those cells in an integral fashion, you wouldn't really expect any loss. The RNA is preserved.
Okay. Another question from Stanley, who asks, have you tested cell viability after storage?
Um, yeah, um, we've looked at over 70 different sample types now, and viability has been examined in pretty much all of those. So it's always looking at viability, functional recovery, and then any specific functional assays that are aligned to that cell or tissue type. And so that is different dependent on the biosample that you're using.
Okay. And then a question from Riyadh, who asks, are these products available in the European market, or do you have to buy them in the USA?
No, they are available globally. So we do provide these samples globally. But the best place to go is to our website. Unless you want to talk to us first, then we're always welcome to talk to you first.
Okay, great. And you can see a link to your website because Atelerix is a sponsor, so you can see the sponsorship panel on the lobby section of this platform. Okay. And another question from anonymous attendee. Um, when you store cells in CytoStore, must you remove the CytoStore first before placing them in the incubator?
Most of the time, yes. So most of the time, you would add the dissolution buffer, centrifuge or dilute out that dissolution buffer, and return the cells to culture. Um, because the gel itself is bioinert, most cells will not like it for longer periods in the incubator. That's not to say you can't do. So the alternate hydrogels that we do use have got a long history in cell culture, used as a cell culture matrix. Um, so potentially you could. Um, we do actually have a product which I didn't. It's a historical product that I didn't present, which is bead ready. And what that allows you to do, rather than having cells within a block in a tube like our cytostore is, you encapsulate the cells within beads. So little hydrogel beads. The protocol is a little bit more involved, but it's still quite straightforward. What you can do at the end of the storage then is just transfer those beads directly into culture. And you can actually do co-culture experiments for short periods, short windows, probably up to 3 days to 1 week with those cells embedded within the gel and look at their influence on a secondary population of cells. And also because the gel itself is completely transparent, what you can actually do is do a lot of imaging of cells dispersed within the 3D matrix. So that is a long answer to getting to the point to say that you can, after I
Okay,
said that you can't.
great. Um, and a question from Maria Garcia, who asks, what about hematology tubes that need to be sent in ambient state?
Yeah, absolutely. I mean, we're more than happy to work with anybody that has a particular format. Uh, with hematology tubes, the actual collection should be relatively in line with the formats that we've already got. If you are just looking at the compositional analysis, or um, if you were looking at any more granular analysis of those blood populations, it really depends what you're looking at. But yes,
Okay, and finally, another question from an anonymous attendee. Do you support validation studies? We
uh,
have a lot of cell lines, not sure how to validate all of them. They're in the hundreds.
yes. I mean, what we would generally do is work with a company to um, conduct a validation study on a select number of cell lines. This will essentially allow them to de-risk the process. So, of course, we wouldn't suggest that people look at 100 or 1,000 cell lines straight away. Select about 10, do a validation study on those, and then roll it out gradually. Um, of course, our technology is very, very universal, but some cells may have a shorter expected shelf life in our product, some may be longer. So it's usually a start slow and then build as you go out.
Right. Okay. And just one other question. Um, when it comes to preserving um, pieces of tumor tissue, what are the size limits? And how does the hydrogel penetrate into the tissue?
Yeah.
Yeah.
So we currently have kit sizes available up to tissue sizes of 3 centimeters. So it's a relatively large piece. Um, and we go down to smaller tubes, which preserve
Wow.
a lot smaller uh, fragments or biopsies.
Gosh.
Um, it's able to protect those samples because our gel protects from the outside in. So the damage that is incurred on tissues during hypothermic storage is usually entry of ions and followed by water, both into the extracellular matrix causing swelling and also into the cells. So it's that entry of ions and water into the cells, which is exacerbated by ECM swelling,
Mm,
that causes those cells to fall apart. So
right.
if you're able to protect from the outside in, you're able to prevent most of the damage. And because it's at hypothermia, you're not really having any activity of cells within the center of the tissue. So you're not having any necrosis. So you're able to prevent that.
Wow. That's amazing. I was thinking that samples would need to be broken up into millimeter, you know, 2 or 3 millimeter diameter fragments, but no.
No, we want to avoid having any manipulation at the surgery.
Yeah.
It increases risk of contamination, increases risk of non-uniformity, it increases risk of the clinician or nurse or path lab just giving up and throwing it in the bin.
Right.
Um, it's so we keep it as simple as possible.
Fantastic. Okay. So that brings us to the end of the questions. So thank you very much, Steve. That's really interesting. And yeah. So if you want to find out more about Atelerix, have a look on the web platform before you leave, and you'll see contact details. And yeah, so thanks, Steve. Thank you to everybody for attending. And also, I should tell you that this webinar has been recorded, and the recording will be available on the Biosample Hub YouTube channel. Yeah, with that, I'll say goodbye. Hope to see you at a future Biosample Hub webinar.